Hi, welcome back. Today we will find the values of n that will make square root of n factorial plus 7 an integer. So when does square root of n factorial plus 7 an integer? N factorial denotes the product of n and its decreasing consecutive integer. So n factorial equals n times n minus 1 times n minus 2, so on until 3 times 2 times 1. Okay, so we let n factorial plus 7 equals k, where k is a positive integer. Now, square both sides, become n factorial plus 7 equals k square, become n factorial equals k square minus 7 by transferring plus 7 to the other side. Instead of finding the values of n directly, we will find the values of k that will make k square minus 7 in the form of the product of the consecutive integers, which is the n factorial. We notice that if n is greater or equal to 2, n factorial is always even, because n factorial is the product of all consecutive integers. So for n factorial greater than or equal to 2, always contain 2, and that will make the n factorial even. If left hand side is always even, then the right hand side, the k square minus 7, must also be even to have an integer solution. If the right hand side is even, then k square must be add. Yes, add minus 7, 7 is add minus add is even, hence k must be add, and k must be greater or equal to 3, so that the right hand side is non-negative. If k equals 2, we have 2 square minus 7 is negative 3. We don't like that to happen. So far we have k must be add and greater or equal to 3. Let's substitute some values of k. K equals 3, 5, and 7. So when k equals 3, n factorial equals 3 square, 9, minus 7 equals 2. And 2 denotes 2 factorial. When k equals 5, we have n factorial equals 5 square is 25 minus 7 is 18, and 18 cannot be represented in n factorial form. 3 factorial is 3 times 2, 6, and 4 factorial is 6 times 4, that is 24. So 18 cannot be represented by any n factorial form. When k equals 7, we have 7 square is 49 minus 7, we have 42, and 42 also cannot be represented by n factorial form, because 4 factorial is 24 and 5 factorial is 120. Okay, we stop for k equals 7. We notice when n is greater or equal to 7, n factorial is always divisible by 7, because the multiplier of n factorial already includes the 7. For n greater or equal to 7, let's divide both sides by 7. So the left hand side become n factorial over 7, and the right hand side k square over 7 minus 7 over 7 is 1. So we have k square over 7 minus 1. Now, for n greater or equal to 7, the left hand side is integer, and the right hand side we have k square over 7 minus 1. Minus 1 is an integer, so hence k square over 7 must also be an integer to have a solution. So we have new conditions for k for n greater or equal to 7. That is, k must be divisible by 7 and must be added, such that k squared over 7 is an integer and k squared minus 7 minus 1 is still even. To make the right hand side even and an integer, k must be in the form of 7 times 2m minus 1, and m is greater or equal to 1. Now substitute the values of k become n factorial over 7 equals 7 times 2m minus 1 square all over 7 minus 1. So square all, we have n factorial over 7 equals 49 times 4m square minus 4m plus 1 all over 7 minus 1. Simplifying further, n factorial over 7 equals the 49 cancel becomes 7. We have 7 times 4m square minus 4m plus 1 minus 1. And distribute, we have 28m square minus 28m plus 7 minus 1. Now become n factorial over 7 equals 28m square minus 28m plus 7 minus 1 is 6, and we factor out 2, become 2 times 14m square minus 14m plus 3. Dividing both sides by 2, the left hand side become n factorial over 14, the right hand side 14m square minus 14m plus 3. We notice that when n is greater or equal to 7, n factorial over 14 is always even integer, because 7 factorial contain 7 times 6 times 5 times 4 times 3 times 2 times 1, and 14 is 7 times 2. So the 7 cancel and the 2 cancel, and we still have remaining 4 and 6, which is even. So for n greater than or equal to 7, the left hand side is always even. Now for left hand side, 14m square minus 14m plus 3 is always add, because when you input any values of n, 14 times something is always even, and 14 times something again become even. So even plus even is still even. Now we have plus 3. So the right hand side is always add for any values of n. Hence, we have no solution for n greater or equal to 7. If we have no solution for n greater or equal to 7, then we can only rely when n is less than 7, and that is when n is equal to 2, which is n factorial equals 2 factorial. So we have only one values of n that will make square root of n factorial plus 7 an integer, which is n equals 2. So that is square root of 9 equals 3. That's all. Thanks for watching.